Hello, this is Eric. We're back. Here we are in the second video. In the first video, we showed how to create the gears and make a drawing. And what we're in the process of doing now is trying to constrain the gears relative to the drawing so that the only thing the gears can do is rotate. So the first thing that we will do is select the bore of the gear, go to Assembly, choose Mate. And what we want is a concentric mate, and if we select the circle, we see that it gets placed correctly. Okay, and now we do the same thing again. We've chosen the edge, or the center, or the rim of the bore. It's concentric. We'll choose the small circle. We'll take that one. Okay, we choose the bore again. We want concentric and the small circle. Okay, we'll take that. Now, if we come out, and what we can see, if we look in our view cube, what we can see is it just happens that these gears are fully are positioned, but on the plane. But they're not really stuck there. You know, you can see that we can move them, and what we really want is to have them on the plane. So if we rotate just slightly, okay, now we can see the face of the gears and the plane. So if we choose the top plane, select Mate. In this case, we will have a coincident type mate. We'll select the gear face, and there it is. Now it's mated. We have to escape out, go back, select the top plane, select mate, coincident, and select the gear face. We'll take it, escape, select the top plane again, back to mate, choose coincident, and the gear face. Okay, we'll take that. Now we see that our gears are reasonably stuck together exactly the way we want them. Except I want to have the big one on the left somehow. Let's try that again. There we go. Well, except there. Okay. Now we will close the mates, and what we can see is that the gears will rotate, but it's not a very intelligent rotation, and then the gears don't seem to really know about each other. And what we'll do is we'll kind of carefully try to position these gears so that they're meshing properly. So if we tried to start rotating them, they would mesh. Okay, so now we can arrow out, and what we will do next is go to Motion Study, click on that, and the first thing that we want to do is establish a contact relation between the large gear and the middle gear. So I hold the Control key down. Now I will establish a contact between the two gears. Oh, and also we need to be in motion analysis mode. Okay, now we've got a contact. We see our gear 1 and 2, which is the large and medium. We will leave a material as acrylic just because our machine is actually made out of plastic. If we were interested in modeling this more accurately, we might select greasy steel as a contact type. Same deal again, Control key, and we will establish the contact between the medium and the small gear. Okay, same deal. We're happy with that. Okay, the next thing that we need is a little motor to drive the gears. We're gonna drive it starting from the small gear. If we select this bore, that's exactly what we want. And when we see that red arrow, we know which direction it will rotate. I'm going to choose 6 RPM just because that's about what our computer can handle in terms of animation power. Okay, now if we click on this calculator icon, it will calculate the rotation, and we see that it looks like it's rotating correctly. If we go to this box and say that we want to play it in a loop, that is, just keep playing it over and over, and then click on the play button, we see that it's rotating correctly, and the gears are meshing, and the rotation speeds are proportional to their number of gear teeth. We can speed that up a little if you like. Here's 2x, and I don't know. I think it will work at 5x, and that's, you know, I think that's a little faster than what your eye can really follow. So we'll go back to 1x. So here's our motion study. I think this is pretty sharp. I like it. Okay, well, we can stop this by hitting the square. We can minimize it to get rid of it. I'm going to hit save again just because I want to save the motion study. And the next thing that we're going to do is to export our gears off to Cura. And so what we want to do with Cura is to first thing is we will select File and then say Save As, and we will choose an STL format. STL is Standard Tessellation Language. You might say it's Standard Triangle Language, but it really means tessellation. And if we say Save, and this is exactly what we expect. We've got 3 gears, we've got 3 files, 3 gears. It all makes sense. We say yes. Cool. Okay, that was pretty easy. So if we minimize SolidWorks and go to our file manager, what we will see is that our STL files got created exactly the way we want it. And because it's a little confusing, because we actually ran this we ran this one before, so we can get rid of these kind of confusing extra versions. Okay, so we've got our gears. If we don't, and we see that Cura is associated with this file type of .stl, this is our large gear. So if we double click on this, it should start Cura. And Cura is sometimes a little bit slow to load, and in some cases it completely fails to load. It doesn't start up at all. So okay, but in this case it looks like it's going to start, and that's good. It'll take us a couple minutes. Cura is our slicing program, and it takes the STL definition of our solid object, and it breaks it up into layers so that our 3D printer can print each layer, one layer after another. We start with the bottommost layer, and build it up onto the top. So once the user interface for Cura launches, which we expect to see any moment now, well, maybe not. Like I said, sometimes Cura is a little bit slow to load, so we'll try and launch Cura directly. Just launch nothing but Cura, and it sort of seems like on the second try it gets it, but and it seems to load a little faster. I don't know if it's something about disk caching or whatever, but anyway, here's Cura, and what we'll do is we'll open a file, open files, and we'll open our large gear, and here it is. Here it is in Cura. But if we tried to print it exactly like this would really be kind of difficult because there'd be a lot of supports and overhanging stuff. So what we want to do is select our object and then click on Rotate. We'll grab this red handle here, and we'll drag it down so that it's at 90 degrees. There's 90. If we let go of the mouse, it plops down. It's exactly what we want. Now, if we look at our Cura settings here, I've selected low quality. Low quality is perfectly good for prototype. It works. It's perfectly good. I've chosen 20% infill just because it prints much faster at 20% density than if it's fully 100%. And 100% is a solid part. You know, that's completely solid plastic. And for what we're building, 20% is adequately strong, and we'll save some money on filament as well. Okay, if we look down here, the support checkbox is unchecked because we don't have any overhanging parts that need support. I always use a skirt just so that if I'm going to have any first layer adhesion problems on my printer, they will get detected before it gets too far. If the skirt doesn't stick to the plate, we can stop and try and fix that. Okay, well, once we've got things positioned and our parameters set the way we want, we click Slice, and this goes fairly rapidly. It estimates that it's going to take 1 hour and 53 minutes to print. Now, I've found in reality that it typically prints faster than that. One of the things that you can do in Cura is perform a preview. If you take this bulb over here on the right and drag it down all the way to the bottom, it shows you the first layer. If we drag this bulb all the way to the left, we're at our exact starting point. If we click the play button, what you'll see if you arrow in or zoom in here is you see our extruder, a simulation of what the extruder actually does. And here it is starting to make our skirt. So we can drag this along and speed it up a little bit. And here's our skirt. Now it's going around the outline of the gear. Second outline. Okay, pretty good. Now it's doing the first layer of the bottom. Okay, that's pretty good. Okay, and then you can drag it a little further up here. Say we're up at midway through it, and we come back to the middle, and let's say that we say go. What you can see now is that it's now creating the well, I'm gonna try and make this run a little faster here. Okay, what it's doing at this point is it's doing the infill pattern. This is what your 20% infill pattern looks like. It's an internal honeycomb of the actual of the part. And it's kind of interesting to watch this in simulation, and it's also kind of interesting to watch the actual printer. But anyway, all right, if we drag it all the way up to the top, that's a completely finished print or finished part. That's what it looks like when it's done. We say save it to the disk. I'm going to rename this as Large Gear Try 2. Since we already have this from an earlier iteration. All right, I'm going to save it, and it's all done. It's saved. Now, what you could do with Cura is you can drag another part in here. Here's our mid-size gear, and now you see, wow, here it is again. It's a little bit cattywampus. We'll rotate it. We want it at 90. Well, all right. We'll keep rotating here. 75. Did it get 90? I hope so. Well, we'll see. Huh. Well, now it seems like our parts are obscuring each other, so we'll say arrange the parts, and in this case, I'm just not absolutely sure that the part got positioned correctly. Okay, that's better. All right. And so if we slice this, we can see that it will show us two will show us two parts. And what we can see is that this thing didn't get properly rotated. And we'll try and drag it again here to get it to 90%. Well, all right. Just we didn't. Okay, how's that? All right, try to slice again. Now, I generally don't try to ever print more than one thing, just because the printing process seems to screw up a lot. Well, anyway, that's basically all that we need to do with Cura. So we can close it, and if we go out to our file manager, we can see that we've got some G-code files out here, and we can send those directly to our 3D printer. In this case, we've got a large gear. We can print that. Okay, I'm going to hit pause again, and we'll go to our next video where we will see how to set up the complete motion study. Okay, here's pause.